So here's the web truss, and again, you've got it locked in at the elbows, and now right here it turns into tension because it's actually picking up its strength from the peak, and it creates a solid point to post with these webs. So that's, and then this little model here can be replicated for 60 feet. You get your points locked into the plate, you hang from the ridge, you get a solid place to post up, you hang back down, post up. And the only reason for having this post here is if this span
is overspan. Yeah.
Is overspan. Yep.
Right.
That's it. And now the same principle here for the knee braces. It's a little bit. Take a look at it here. It's we'll take this one first. If this was like a post situation where it needs to resist thrust or a load from the side, the thrust is here. Now you get compression at these 2 points and tension right here at the post. So if you're looking right here and it's pushing this way, as soon as these guys compress, then it's going to try to blow it out. So it's actually trying to come apart. And then vice versa on the other side, up at the post, it compresses, just pushes one against the other, and it tries to come apart at one of these 2 points. And that's where getting the pegs far enough in with a deep enough tenon really is where the rubber meets the road as far as total strength. Because the compression, 2 pieces of wood, I mean, that's real strong.
On that top one there on the left, that where the blue arrows are,
Yeah.
it actually would be almost tension on one side of that, and compression on, like, tension on the top and compression on the bottom of that joint right there, wouldn't it be? In a sense?
Well, I see kind of where you're going, but as soon as these babies lock up here, then it's I guess, yeah, you would have, but it's what happens here is as soon as you get all that pressure there, this guy tries to fall away.
Right. Gotcha.
So it kind of
doing.
yeah. As soon as the just because these guys. And here's an example of some tenons. And if you look right here, this is called a spline. And that is one way to connect beams. The post is bigger, and the 2 beams pocket in to the post. And what you got is like a 2x8 that mortises into both sides of the beam, pegs connecting. It's an old-time strap. Basically,
like a big knife plate in there.
You could do a knife plate.
Is that what it kind of is, like a knife
No,
plate?
this here is it's kind of a little bit dark there. It might even be 2.5 or 3 inches wide because everything's so big, and it hangs down X amount, and is pegged to the post also, and it's got a little decorative cut to it. It's part of the art.
Part way up into the beam then?
Yeah, it goes about 4 inches.
Okay.
And then it typically hangs down a couple inches.
What's the purpose of it hanging down?
Art.
Just art. Okay.
Yeah,
just
I
for
mean,
looks.
Just for looks. Yep. That's 98% of my job. Yeah.
Regular base, yeah. Put together with steel bolts and then put pegs on the outside.
No.
Well, sometimes we do that. I'm a pragmatist.
He does a lot of it with oak pegs.
Yeah, most of the oak pegs are the most economical. If I can do it with that, I'm better off. And not only that, then it's more of the, the true blue. Yeah. But I'm a pragmatist, and I feel like the timber framers of 300 years ago, 500 years ago, 1,000 years ago, if they could be transported to today, and if I was a guy who was hacking down my own trees and squaring them up and just totally with hand tools, they would chew me out. You have access to all this, and you're doing X?
Yeah. You got steel bolts. Why aren't you using them?
Yeah.
Yeah, they would be aghast. And so I try to follow that mentality and still include the art when I'm doing this.
Question, as long as you're talking about that, didn't the Swedes have a reputation, the old styles construction, to do this kind of?
Yeah, sometimes it's confused with logs.
Swedish Cove.
Yeah, the Swedish Cove.
Oh, okay.
Yeah, they kind of really had a special way of doing that.
With the logs.
Mhm,
Okay.
with the logs. So lateral bracing systems, these words I've kind of coined for just, I don't know if they're going to be more confusing or not. A cantilever system, shear diaphragm, load to footprint, a knee bracing, which we kind of touched on already, through tenon, and a crux system. And there's one more I'll bring up too as we get to the end. So the knee brace system, here you've got the knee brace with a tenon into the post, resisting both sides, as long as the post will take the load of whatever's, won't break. And it's kind of a funny deal. A lot of these old barns with this knee brace system, they'll have a knee brace that's way up on the post. And for me, that ratio, I like a good solid ratio. I mean, I don't want a whole bunch of flex. On these barns that have a knee brace, 16 foot up in the air, some of that strength is in the ability to move with the load and not fail. You get so much flex in that post that that triangle doesn't have to perform as well, because by the time that wind, kind of like a vine maple versus an oak tree, I tend to be more solid. I don't like the shaky part. It is impressive, like with pole buildings, a 6x6 post, how much flex. If you go up 14 foot, I mean, they flex like crazy, but that's, part of the strength. Okay, shear diaphragm and a knee brace, and this is something I hit a lot. Most of the times, to make it easy for engineers and whatnot, we'll just say we're picking up the load in the diaphragm, in the roof that's coming out. And in this case, a steep roof like this, it gives you, like we talked about with the low thrust, it's strong that way. One other place that when it's real steep like that, it doesn't give you as much shear value. When you sheet both of them roofs, there's kind of a lot of, you start pushing and moving, it's not going to be as strong as a 312 or a flat deck. That's, locked in. You get it steep like that, and here we're coming out, 6 feet, and so it's for the engineer's purpose. The roof is going to keep it from falling over, and this, with the short posts and whatnot, I feel like the post will catch the load before the roof will. But either way, it's not coming down.
So, when you do these like this, I mean, this is some of your work, I'm
Yeah.
assuming. How much of that do you actually do? Do you sheet the roof and do the connection to the house? Have you been involved in the framing of the house? I mean, I know you used to frame all that stuff. Do you do all that stuff there, or do you do just the timber frame part of it?
On this one here, we got it ready with the decking at the right level, so they could frame off that and sheet over their rafters and tie the whole works together with their plywood. So it was ready. All they had to do was run the plywood out and nail it in, and they're good to go.